Hello, my name is George Malik, and I would like to introduce you to my real-time project for my HDIP in data analytics. For my project, I chose to engage in research on two data sets which contained information based on electrical consumption, generation, pricing data, and weather from Spain over the course of 4 years, from 2015 to 2019. I retrieved this data from Kaggle, and it's a widely used data set that has been explored many times. However, due to the large amount of variables, there are never-ending possibilities and avenues for analysis and exploration. I started off by installing packages and adding in libraries which I thought were useful, and also did that as I went along. And I then read in the first data set, which was the energy data set. 35,018 observations of 22 variables. The first major issue I faced was trying to standardize the times due to the different time zones being used in the data sets. After some research, I found the ASPOS-XCT function was the best for this. I removed the time zones, showed it as a calendar date, and then began formatting the data so that I could use it a little bit more appropriately for what I wanted to do. Now, before I put the data set in here, I actually had a quick look over it using Excel, as it came in a CSV file format. I removed the columns that I didn't want, checked data integrity, and removed variables that didn't conform to the integrity that I needed for this, or were not necessary or useful for what I wanted to explore. Before I begin going through the data set, I should explain that of the many avenues I could have went down, I decided that the two research questions I was most interested in were: could I predict the price going forward, the price of energy going forward, using past data on energy and weather? And also, how does energy generation and weather impact the price? To begin with, I began to aggregate the data to allow me to explore it more appropriately. I also found this challenging, but using aggregate and subset, I was able to overcome this. So to begin with, I just had a quick look at price of data over the days of the 4 years, over the weeks, and over the months. And then I began to look at things a lot more closely. A lot of this is just preparation for moving on. I began to then look at means over the years, and then developed a nice matrix which allows me to quickly compare all of the different variables over the 4 years in a nice table like this, so to allow me to make quick comparisons before I moved on. I then aggregated the years with the means of each month, again to allow me to make nicer looking plots, which I could then use to come up with some conclusions. As we can see, the price per month across the 4 years didn't differ too much, apart from 1 year, which was 2016, where it was way down. The other 3 years, it has remained pretty similar throughout. Quickly check normality of prices and distribution of prices, and it seems quite normal. Used ACF to measure the price over time, and then began looking at plots of the energy generation types. They begin to become a little bit more advanced the further down I go. Here I broke them down into years, so here's one example. That's a comparison of renewables in the year 2015, as it says here. And as we can see, there seems to be an inverse relationship between fossil fuels and renewables. It's quite faint in this, but we see it further down. We see it more evidently. But as you can see, in the first half of the year, fossil fuels is lesser used, renewables is used more, and then about 6 months into the year, it swaps around, and we get a much clearer view of this when we look at this plot here, which shows us again the different energy generation types over 4 years, with each of these lines indicating a year, split into months this time, but we can see that same pattern again, where 6 months into the year, renewables is what's used mostly at the start, or more often than it's produced, more often than fossil fuels, and then there's a switch. It's less evident here, but again we see the renewables are highly generated in the first half of the year, and towards the latter half of the year fossil fuels becomes more used. 2017, it doesn't really follow that pattern as much. However, fossil fuels do increase towards the latter half of the year, and again we see it here where renewables are used more in the first half of the year, and then less so with fossil fuels being produced more as the year goes on. I tried to then have a look at how price comes into this, and perhaps the one that we can learn the most from is a comparison between fossil fuels, which is here in the red, and the price, which is here in the green. There seems to be some sort of correlation between them there, because they seem to trend or move in a very similar manner. When we introduce renewable energy, which is in blue, it doesn't follow the lines as closely. In fact, if anything, at times we can see here what appears to be an inverse relationship. We then moved on here and compared them again, just in a different way, to try and get a better look at that relationship. And again, it looks like fossil fuels and price are more related than renewables, which seems to spike again in the first 6 months of the year, and has an inverse relationship. When it's being produced more, price seems to decrease, and fossil fuels are produced less. I then introduced the weather data set, into my research, one major issue was some of the variables were not of good integrity, or there was inaccurate data um, included. For example, I found pressure was totally off. The data didn't make any sense, so that column was removed alongside some other ones which weren't needed for research. The temperature was given in Kelvin, so to change that we used this nice and easy formula. Same process was used then to standardize times and aggregate data by different time frames. And similar tests were then carried out to see how it impacted price, as well as getting some nice ideas of how different temperatures means changed over the years, and also having a look at how cities, how it differed between cities, means of temperatures and weather differed between cities. Also use box plots to visualize this as well, which can sometimes be a lot easier. Some increased wind in Valencia compared to the other cities. I then merged both data sets together to then begin to really look at price and correlations between the variables, creating this correlation matrix here. And as we can see, there was some correlation, moderate, but some. As expected, fossil fuels had a moderately strong positive relationship with price as it increased. Price increased, but moderate only. The load increased as did price. We see some negative relationships with moderately negative relationships as well. For example, fossil fuels and renewables is pretty conducive to what most people would think. And anything else I want to highlight here? Not really. There's a nice matrix here. Humidity and temperature actually have inverse relationship, it would seem. 0.57, and we can see it here as well on the correlation matrix. We then moved on to look at weather and price. Humidity and temperature appear to have an inverse relationship. We've seen that, and there doesn't seem to be any huge indications of how weather would increase price from the visual plots, but still worth doing. When we did, one interesting point was wind seemed to have a relationship with price, especially wind speed. When wind speed, which is here in the red, went up, we see a decrease in price. Again, when it went up, we see a decrease in price. When it went slightly down, we see an increase in price. One possible theory is that it could be because of wind production. When there is less wind to support wind production, then the price of renewable energy would go down, and the renewable energy production would go down, and therefore the price would increase. if the theory is correct. So I began to model things